The concept of stealth technology emerged from the need to evade radar detection. Radar, which uses radio waves to detect aircraft, revolutionized air warfare in the 20th century. However, as radar technology advanced, so too did the methods of countering it. Stealth technology aims to minimize an aircraft's radar cross-section, making it significantly harder to detect. Early attempts at reducing radar signature involved using radar-absorbent materials and designing aircraft with minimal flat surfaces. These efforts, while helpful, did not render aircraft truly invisible to radar. The breakthrough came with the development of computer-aided design and computational fluid dynamics. These technologies allowed engineers to create aircraft shapes that could scatter radar waves, dramatically reducing their radar cross-section. The United States pioneered stealth technology with aircraft like the F-117 Nighthawk and the B-2 Spirit. These aircraft, with their unconventional designs and extensive use of radar-absorbent materials, demonstrated the game-changing potential of stealth in air combat. The success of American stealth aircraft spurred other nations to invest heavily in this technology, leading to a new era of stealth fighter development worldwide. In the late 20th century, as the United States fielded its first stealth fighters, Russia recognized the need to develop its own fifth-generation aircraft. The Russian Air Force sought a multi-role fighter that could match or exceed the capabilities of its Western counterparts. This ambition led to the launch of the Perspektivny Aviacyjny Kompleks Frontowej Aviacji, or PAK FA program, which aimed to develop a next-generation fighter jet. The PAK FA program faced numerous challenges, including limited funding and technological hurdles. Despite these obstacles, Sukhoi, a leading Russian aircraft design bureau, was selected to develop the new fighter, designated the T-50. The T-50, later renamed the Su-57, embodied Russia's ambition to field a stealth fighter capable of competing with the best in the world. The Su-57's development was shrouded in secrecy, with limited information available to the public. This secrecy, coupled with Russia's history of exaggerating its military capabilities, fueled speculation and debate about the true capabilities of the Su-57. Nevertheless, the aircraft continued to progress through its development, with its first flight taking place in 2010. The Su-57, nicknamed Felon by NATO, boasts a distinctive design that reflects its intended role as a highly maneuverable and stealthy air superiority fighter. The aircraft features a blended wing-body configuration, with smooth curves and minimal protrusions to minimize its radar signature. Its twin engines are embedded in the fuselage, further reducing its radar cross-section. The Su-57 incorporates advanced avionics, including a powerful radar system and a sophisticated electronic warfare suite. Its cockpit, designed for a single pilot, features a large touchscreen display and a helmet-mounted display system that provides the pilot with a 360-degree view of the battlefield. The aircraft is armed with a variety of air-to-air and air-to-surface missiles carried internally in its weapons bays to maintain its stealth profile. The Su-57 is designed for super-maneuverability, enabling it to outmaneuver its opponents in close-range dogfights. It can perform advanced aerial maneuvers such as the Pugachev's Cobra, which allows it to quickly change its direction and gain an advantage in a dogfight. This focus on maneuverability reflects the Russian air combat doctrine, which emphasizes close-range engagements. The Su-57's stealth capabilities have been a subject of much debate and scrutiny among defense analysts. While Russia claims the Su-57 possesses advanced stealth features, some Western experts remain skeptical. They argue that the aircraft's design, while incorporating some stealth elements, may not be as refined as that of American stealth fighters. One of the main criticisms leveled at the Su-57 is its apparent lack of attention to detail in reducing its radar signature. For example, the aircraft's engine inlets and exhaust nozzles are not as well shielded as those on the F-22 and F-35, potentially increasing its radar visibility from certain angles. Additionally, the Su-57's use of external pylons for carrying weapons while providing flexibility compromises its stealth profile when carrying external stores. Despite these criticisms, it is important to note that assessing the stealth capabilities of an aircraft is a complex endeavor. Radar cross-section varies depending on the angle of observation, radar frequency, and other factors. Without access to classified data, it is difficult to definitively assess the Su-57's true stealth capabilities. Section 5. Power and Performance. The Su-57's engines in focus. The Su-57 is powered by two Saturn AL-41 F1 turbofan engines, which are derivatives of the engines used in the Su-35S fighter jet. These engines provide the Su-57 with supersonic cruise capability, allowing it to sustain supersonic speeds without using afterburners. This capability is crucial for reducing fuel consumption and extending the aircraft's range, particularly during long-range missions. However, the AL-41F1 engines have been plagued by technical issues and delays. Reports suggest that the engines suffer from reliability problems and may not deliver the desired level of performance. These issues have hampered the Su-57's development and raised concerns about its operational readiness. To address these shortcomings, Russia is developing a new engine for the Su-57, known as the Izdeliye-30. This engine is expected to provide increased thrust, improved fuel efficiency, and enhanced reliability. However, the Izdeliye-30 engine is still under development, and its integration into the Su-57 is not expected until the latter half of the 2020s. Section 6. Digital Battlefield. Advanced avionics and weaponry of the Su-57. The Su-57 incorporates a suite of advanced avionics and weaponry designed to give it an edge in combat. Its N036x radar system provides a wide field of view and long-range detection capabilities. The radar can track multiple targets simultaneously and guide long-range air-to-air missiles with precision. In addition to its radar, the Su-57 is equipped with an electro-optical targeting system that allows it to detect and track targets passively without emitting any radar signals. This passive detection capability enhances the aircraft's situational awareness and reduces its vulnerability to enemy detection. The Su-57 can carry a diverse payload of air-to-air and air-to-surface missiles, including the hypersonic PAK-47M2 Kinzhal missile. The Su-57's avionics are designed to be highly integrated, providing the pilot with a comprehensive and real-time view of the battlefield. This integration allows the pilot to make rapid decisions and effectively manage the aircraft's sensors and weapons systems. The aircraft's advanced electronic warfare suite provides protection against enemy radar and missiles. Section 7. The future of air combat drones and network-centric warfare. The Su-57 is envisioned as a key node in Russia's future network-centric warfare doctrine. Designed to operate with drones, the Su-57 acts as a command platform for drone swarms. These drones extend sensor coverage, provide targeting info, and carry out attacks. Integrating drones with manned aircraft is a key trend in future air warfare. Drones reduce risk to pilots, increase endurance, and operate in contested airspace. The Su-57's drone coordination enhances its combat effectiveness. Highly networked, the Su-57 shares data with other aircraft and command centers. This enables real-time coordination, enhancing situational awareness and air operations. Section 8. Production woes and future prospects. The Su-57's uncertain path. Despite its advanced capabilities, the Su-57's future remains uncertain due to production challenges and budgetary constraints. Russia initially planned to procure hundreds of Su-57S, but these plans have been scaled back significantly. As of 2024, only a handful of Su-57S are in service with the Russian aerospace forces. The limited production run is attributed to several factors, including the high cost of the aircraft, technical challenges in its development, and the impact of Western sanctions on Russia's defense industry. The Russian economy has been struggling in recent years, further limiting the resources available for defense spending. Despite these challenges, Russia remains committed to the Su-57 program, albeit at a reduced scale. The aircraft is seen as a symbol of Russia's technological prowess and its ambition to maintain a leading role in military aviation. Russia continues to invest in the Su-57's development, with plans to upgrade its capabilities and integrate new technologies in the coming years. Section 9. Evaluating the felon, the Su-57's impact on global air power. The Su-57 represents a significant development in Russian military aviation. It is a highly capable aircraft with the potential to challenge Western air superiority. Its advanced avionics, maneuverability, and stealth features make it formidable in air combat. However, its limited production and technical challenges suggest it won't alter the balance of power soon. Nevertheless, the Su-57 highlights Russia's enduring military capabilities. Its development has spurred innovation and competition in the global fighter jet market.